Welcome to the second in a series of video guides we put together for our torque, drag and hydraulics modelling software, TDH. As with the first video, this one is designed to highlight its benefits and to provide users with practical insights relating to the modelling of various common engineering scenarios. TDH is designed to bridge the gap between the office and rig, allowing engineers to proactively manage drilling performance on the basis of what's measured. In the first video, we looked at using the software to model the requirement for floating a string of 9 5/8 casing in the hole. This time, we'll look at a technique shrouded in mystery and myth: backreaming. We're going to select the 12 1/4 inch drilling scenario. Then I'll click on the WB box, which brings up the casing and hole configuration on the left. And you can see the formation tops associated with the wellbore on the right. Next, let's take a look at our drill string. We're modelling the string as 3 sections: a 5 1/2 inch drill pipe, 200 metre section of 5 1/2 inch heavyweight and about 40 metres of 8 inch collars which mimic the BHA. If I click on the AN button for analysis, we're into the meat of the software. You can see at the top left I've got torque and drag selected along with driller's analysis. I'm going to look at the situation when tripping or rotating off bottom, which is the mode we're usually working in when gathering data for proactive hole condition monitoring. You can see the coloured lines: blue for slack off, green for rotating off bottom and red for pickup. You can also see that we've added data whilst we've been drilling the section: breakover and steady state data shown by the triangles and circles plotted on the chart. You can see that the rotating weights line up quite well with the model, meaning that the model is well calibrated with our actual data, and that we can use this with some confidence when interpreting what we see. As you can see, our actual values are following the 0.3 friction factor trend line, which gives us about £200,000 of overpull capability at TD, should that be required. Now let's have a look at the surface torque. Again, I'm plotting rotating off-bottom torque, or ROB, my breakover torque and my drilling torque so I can identify trends as they developed. We need to make sure our chart hygiene is also up to scratch, with all the relevant torque limits on there. As you can see from the data, we're well below our 100% makeup torque limit, never mind our pipe body torsional limit. To see what's happening when we're reaming or drilling, we need to switch over our analysis to reaming drilling mode and tell the software which direction we're moving in, how fast we're rotating, and how quickly we're pulling out of hole. Let's swap over to a prepared scenario we have set up that looks a lot like the last one, with slightly different RPMs and tripping speeds. This scenario has some actual backreaming data associated with it, which will help us with our analysis. You will notice that the hook load lines are now much closer together when the string is rotating, because we're translating the axial drag into torque. Zooming in, there's good agreement between the rotating off-bottom prediction and the measurements, giving us confidence in the model. Looking at the surface torque, unsurprisingly the values have increased. This comes from the extra tension in the string introduced when backreaming. The string effectively becomes stiffer due to rotation, increasing contact forces through build sections. These increased contact forces are manifest as an increase in measured torque at surface. In this example, our actual measurements follow a low friction factor as the well deepens, indicating that our hole cleaning practices are effective. The real data is entered into the model by clicking the Field Data button and simply inputting data in the columns of your choosing. You can even create your own column in the unlikely event that what you're measuring is not there by default. Right-click on the chart and scroll down to compare, then click Freeze All Series. You will see that your modelled lines turn grey immediately. Next, I hit the tripping/off-bottom radio button to switch over to this modelling algorithm, and then I'm going to reanalyze the model without the direction of travel, rotation or tripping speed. What should we see? So let's say you want to compare the backreaming model against your off-bottom model to see what effect the practice will have on your loading envelope. My new model is showing up in red, and I immediately notice a reduction in surface torque across all the modelled friction factors. Remember, the new model is showing the surface torque with the string stationary at a given depth with no extra tension due to pipe movement. If I put my torsional limits back onto the chart, you'll see that it's possible to exceed a make-up torque limit while back-reaming at higher friction factors. In fact, when back-reaming, our 0.35 friction factor load line exceeds our 90% make-up torque limit at TD, whereas our tripping 0.45 friction factor does not. This may be a critical piece of information at some point. Finally, there's no point in writing a book which never gets read, so I click on R and open the reporting module. I've selected my surface torque output from the default template drop-down list, and as you can see, TDH has created my comparison chart between the back-reaming scenario and the standard tripping scenario. It's also pre-populated the parameter box so the person reading the chart can audit the results for themselves, which is important in avoiding the black box approach. I can also add a text box explaining what the grey lines are to avoid confusion at a later date. From here, I can export to an image file, a PDF file, to Microsoft Word, the clipboard, or even any printer I've set up. In summary, it's very easy to quickly put together a model highlighting the sort of loading envelope your rig is going to see should back-reaming become an option or indeed a requirement for getting out of hole. Don't forget that even if you have the margin to undertake back-reaming effectively, you'll also be subject to the inherent risks associated with it. From my perspective, it's hard to get packed off tripping on elevators with a strictly controlled overpull margin, and it's usually faster overall too, so make that your base case. But should you need to backream, good practice suggests making sure you know the loads and limits well in advance of actually needing to use them. That's the key. Thanks for taking the time to watch and listen.